Hi, my name is Emmanuel Garces. I'm from Mexico and I work for Wolfram. I'm going to talk about geographic visualization. The content of the talk essentially is a very brief overview of geographics. Francisco is going to talk about this in more detail tomorrow at 2 p.m. in the same place. And that covers some primitives that we can use with geographics and some functions we have for visualize geographic features. Then I'm going to talk about GeoHistogram. That's a new function in version 11. Then how we can combine or interact with different visualization functions using show, and finally some applications. So as you probably know, geographics with no input shows our local location. So
you want to increase the magnification to 150 or 200?
Okay. Let me see. It's okay? So for this case, evaluating this here in Champaign shows a map of our current location. We can also show a map of the world by typing the string world. And of course, there are other options we can set into this function, but tomorrow there will be more details about this. We can also show a map of the United States, or probably just a city, by inputting it with an entity, right? So this is basically what geographics does, and we have different options. So it's just a very brief showing of geographics that Francisco is going to talk tomorrow more in detail. But it's the base of every geographic plot that we have. So there is an example using different options for geographics. As you can see, we can set the geo projection, we can set the geo background, and in this case, we are showing just the contour. We can set on and off geogrid lines and change the scale bar. In this case, it's imperial. We can put some geomarkers using these wrappers. For instance, in this case, we are showing London City. So there are different options for geographics that, as I said, Francisco is going to talk about more in detail tomorrow. There are primitives we can use and put things over the geographics plot. Brett talked about one of them, GeoPath, for instance. We have a path from New York City. That's the distance, and that's the direction, right? And we can specify different kinds of paths. Another primitive we have is GeoCircle. In this case, we are showing a circle centered in this lat-long position. And we specify a radius of 3,000 kilometers. So as you can see, it doesn't seem like a perfect circle, right, because of the projection. And okay, we are showing the whole world, the circle in the whole world. So similarly, we have geodisk that essentially it's the same like the circle, but it's this colored, right? There is another primitive called GeoVisible region. In this case, we are showing, we feed this primitive with geoposition and show us what is the region of the world that is visible from that point. In this case, the position of the International Space Station give us geoposition. In this case, you can see there are 4 numbers, because one of them is the time. But no matter of that, we have lat long and the height of the International Space Station, and then we see what's the observable area from that point. We have GeoHemisphere showing us what's the from one point, for instance, here in Mexico City, what's the hemisphere that we can see centering the Earth into this point. So this area is what's observable from centering Mexico City in the world. We have night hemisphere and day hemisphere. You can see both of them are similar, because there is the gray part is the night, and the white part is the day. I took this. I evaluated this yesterday, like at 3 p.m. So it's like about the same right now, probably half an hour difference. So those are primitives that we can use in geographics, right? Besides the primitives, we also have some geovisualization functions. Probably you know some of them. We have GeoList plot that essentially is plotting different entities that have, geo entities. For instance, we are showing here some countries in Asia. Let me change the size of this. Okay, so GeoList plot with a list of entities show us the entities, in this case, countries. Those could be cities or another entities, the geo entities. Or we can fit the function with some time series, right? So we have time combined with a geo entity, and we can use joint to show probably a path or a travel, right? This is one of the functions we have for Geo Visualization. I'm not going to focus in this particular area. I'm just showing a brief overview of them. The other function we have is real region value plot that allow us to show regions along with value. So in this case, we are showing different countries in Europe and some values for each country, and then it's showing us the color for each value, right? It's quite similar to GeoHistogram, but GeoHistogram is going to do things more automatically than region value plot. Okay. So that's a very brief introduction to primitives and functions we have. We have more primitives, but I just showed some of the main primitives because there are a lot of them. Okay. And now let's start with GeoHistogram. This function is introduced in version 11. We don't have 12 yet. Yeah. Okay. I just put this line to change the plot theme because the default colors for GeoHistogram probably are not good for the presentation, so I'm just showing this plot theme. So that's why I put this line. The basic idea of GeoHistogram is we have a set of latitude and longitude pairs of points. Of course, in the world, for instance, we have a table of 30 points of random numbers between some range. And then we're going to show the histogram on the map of those points. As you can see, the default meaning is, as Brett said, are polygons. So we have polygons per each area where there are points. So probably you can see the number here. There are four points here. There are 1 point here, and so on. So the default behavior of GeoHistogram is this. But we can have different specifications for data, not just pairs of latitude and longitude list. We could have a geoposition object of many points. In this case, there are 30 points. There are the lat bounds, long bounds, etc., etc. So we can feed GeoHistogram with an object like this, and the behavior will be the same. The other kind of input we can feed this function is by using entity class. In this example, we are showing the distribution of skyscrapers around the world. So you can see the first argument of GeoHistogram is the data. And in this case, this argument is an entity class. So the second argument I'm going to talk about later is going to be the wide. I mean, how many bins do we want at the wide of the plot? We want to show everything in the world, and of course show an automatic legends to see how colors are associated with countings. So you can see, of course, there are a lot of buildings in this area. I think this is New York, right? We have one in Mexico City, Europe, and so on. So the main idea of this is that we can easily fit this function with objects that we already have, like entity classes, instead of taking the positions of every entity that has coordinates. GeoHistogram does it automatically. We can also feed GeoHistogram with associations, and this means that we can associate every entity with positions like countries, and then make an association to any value. In this case, we have the entity and the population. So GeoHistogram is not going to be counting itself. Instead of that, it's going to make the sum or accumulate every value that we have for each entity, and then apply the meaning processing. So we can see here are the countries in Europe, and then we can see areas where there are more population than others. Okay, so this is interesting because we can associate different values. No? Okay, so we can use weighted data. In this case, I'm using a function to generate weighted data, associating some entities. In this case, those are the largest city of United States, along with their population. This, this wrapper, this function generates the weighted data for the cities and populations. And as the example that I showed before, we are showing areas where there are more people. So, right, there's more people here, and less people here. Now, we are only showing these hexagons. I'm going to talk about different kinds of binning later. Okay. So we talked about data. The ways we can feed the GeoHistogram function using different data. Now I'm going to talk about the specification of binning. As I said, the default behavior of GeoHistogram is use these hexagon tilings. It's one of the more popular way of filling some space. But we have different ways of filling some area, like rectangles. So in this case, I'm using data from Japan. I don't remember what was the data. I think it's, I'm not sure if it's the population of Japan or just the random points at Japan, but I'm using a rectangle binning specification. Okay.
I want to speed through these a little bit.
Yeah. We also have triangles. Okay. Now, we can specify the number of bins that we would like to have at the width of the plot. So if we set 15 bins, it means that there are going to be 15 bins at the columns, because we have here Hawaii. From here to here, there are 15. And okay. We also can specify a total number of bins we want to have. In this case, we have 10 rectangles, right? We could have any number of bins. Okay. We could use quantity to specify the size of the bins. In this case, we are using hexagons of diameter of 500 kilometers. So the diameter of each bin is 500 kilometers. We can mix it but using a different figure for the binning. We can also use, triangles by 500 times 1,000 kilometers. And also we can use an unit of squared area, like acres. So in this case, we are showing the distribution of buildings in New York by using bins of 1,000 acres, right? Okay. Another binning methods include So there are methods that are already in the the academic area, like storages. By the way, this is a default. This is the default meaning for the function. Scott and Friedman diagonist, right? Okay. Now another binning specification is the we can use GeoIdentify name. In this case, we are using the countries for binnings. We can specify an explicit list of bins. In this case, we want the states of France as bins. We can specify a function that essentially takes the bins as an argument, and then you can choose a different binning. In this case, if there are more than 10 points, I'm going to use the administrative division for France, in this case states. But if there are not more than 10 points, I'm going to use the automatic one. So we can use a function to specify the binning. We have a specification of height. Essentially, we just have accountings. I'm showing this example because those are points all over the world in a homogeneous distribution, only to show that these are countings, these are probability, these are intensity that depends on the area. As you can see, the colors change because the area near the poles is different. And we have a probability density function as well. For instance, this is the usual plot of GeoHistogram, but if I use the intensity height specification, then we have a different behavior because the area of each bin is different. Okay. We have options, different options. Okay, changing colors. Okay, let's go. Changing the background of the. Essentially, those are the same options for geographics. We can use different geoprojections, right? We can use georange, plot style, of course. Different themes, as you can see. And we can also, dynamic geographics, you already have heard about it. We can, I'm going ahead because there is almost time. We can use show to combine different plots. For instance, we are using here a GeoList plot, and then some points at some Asian countries, then a geohistogram for those countries, and then I'm going to use show to combine all of the three plots that we have. Finally, some applications. For instance, here we have the density of trees in Champaign, Illinois. We can use dynamic geographics to interact with this. So we can see where are the trees, where are the green areas. We can see the distribution of earthquakes around the world. Finally, okay, we can use, as I said, weighted data. And showing the locations of breweries in the United States. That finally we will get a plot like this showing points where the breweries are and the densities of each brewery. So I think that's an interesting application. And that's it.